Welcome to my YouTube video. In this video we're going to look at mathematics paper 1 from the year 2017, and this is an internal past paper. So now, what are some of the things that we're going to pay attention to? So number one, we're going to pay attention to linear programming. We're also going to pay attention to coordinate geometry. So if you have got issues in these two topics, please kindly pay attention as we dive and go through different concepts behind linear programming as well as coordinate geometry. Okay, so before we go to these two topics, allow me to just solve the first question. In this case, the first question is this one right here. Alright, so our first question is simplify, saying simplify 3x minus, open brackets, y minus 2x minus 3y. So here, because we have seen the brackets, there, what we do is we're going to use BODMAS. So here, BODMAS says brackets of division, multiplication, addition, and subtraction. So let's start first by working on the brackets. So in this case, looking at the brackets, what we'll do is we're going to expand the brackets. How do we do it? We're going to expand the brackets by looking at something that is just right before the brackets. In this case, what's right before the brackets is basically a negative. I repeat, make sure you expand the brackets by just looking at something that is right before the brackets. In this case, it's a negative. So what do you do in this case? You're going to say, you're going to drop down 3x. It's going to be now negative times y. This is negative y. Then negative times positive. Or negative times negative. You're going to get a positive 2x. Then eventually, after opening up the brackets, now you can get this guy the way he is, you drop him down. So that is minus 3y. Yeah. The moment you just do that, I believe you're going to get a mark. So what's the next thing? The next thing is to make sure that you group the like terms. How do you group the like terms? I like telling my students to say each time you're grouping the like terms, you use a copy and paste mechanism. What do I mean? What I mean is pretty simple. It's like this. So if I copy 3x exactly the way it is, together with the sign, it's gonna be 3x. Then which other term has got an x? It's this one. I'm going to copy it together with its sign, of which the sign is always in front of a number. So let's do this. So before you look at the term, the sign that is right before the term is what is going to be the sign of that particular term. So in this case, this is positive 2x. Remember, we're copying and pasting. So we copy that, we paste it over here. Then we're going to get another one. In this case, that is negative 3y. If you do the copy and paste mechanism, you're going to realize to say your negative 3y is right there. Get it the way it is. Then that is going to be negative y. Then eventually you're going to get that guy, copy him and paste. That is negative 3y. Like that, it means that you have managed to do what? You have managed to group the like terms. Because they are like terms, I want you to understand this. Remember that these two here, this as an x, also this as an x, and the x that you're able to see there, the letters that you're able to see there, they're exactly the same, implying that they're like terms. So what do you do? If they're like terms, just work with the numbers. How do you work with the numbers? You make sure that this is, so just work with the coefficients in simpler terms. So this is positive 3. That is 3 plus 2. What is your answer? 3 plus 2. 3 plus 2 is basically 5. What was that letter that was common between those two coefficients? It's basically x. So in short, 3x plus 2x, the answer is 5x. Then we go to this other part. This other part here. This other part, we have got negative y minus 3. So each time you have got a letter like that, in front of any letter where like you can't see the coefficient, you can't see the exact coefficient that is here, like the number that is in front of y, just know that there is y, there is 1. Each time you see a letter there is no coefficient, just know that the coefficient there is 1, implying that right here we've got a 1, right? So because we have got like terms there, we can say -1 minus 3. Remember, similar signs you add and maintain that particular sign, because think about it, that is -1 minus 3. It's more like you're going in the same direction of the number line. At the end of the day, you're going to get what is known as -4y. Then if you're in the exam room, make sure that you extract that answer, you take it on that space, that is 5x minus 4y. The moment you just do that, you've gotten your 2 marks. Make sure the first step is to open the brackets by using BODMAS. We know that we're just going to multiply the negative throughout everything that is in the brackets. Make sure that you remember to say positive times positive, the answer is always positive. Negative times negative, the answer is positive. Then when we have got different signs, we know that when we have got positive multiplied by negative, the answer is always negative. And a negative multiplied by a positive, the answer is negative. Try to utilize these tables showing multiplication of signs. Very, very important. This is very important, especially where negative is concerned. The next question is basically talking about indices. We're going to look at indices in the next video. Just make sure you subscribe, like our YouTube channel, like our videos, as well as switch on the notification bell button so that you will be able to see our videos each time we post. Okay, so this question is coming from coordinate geometry, our main concern, coordinate geometry. Okay, sorry for that. So they're saying the gradient joining the points -2, k and k, -14 is 2. So let's try to get the data. The data is telling us to say we've been given the gradient. In this case, the gradient is normally denoted by m. What is our gradient? The gradient in this case, it is 2. Then we've been given the 2 points. What are the 2 points? The 2 points are, so we've been given the 2 points. The 2 points are -2, k, and we've been given k, -14. So these are the 2 points. Now, what is the big deal about these 2 points? They're saying the gradient of the line joining the 2 points. So I mean there's a line that joins these 2 points. Let's assume this one is point A and that one is point B. So there is a line that is joining these 2 points. So now they're asking after its gradient. That's not really they're asking after this. They have given you the gradient of this particular line. That's what it means. So now let's try to deal with it. So how do you solve for gradient? We know that gradient is equal to, because they have already given you the gradient, so possibly they might have used this formula. They might have used the formula y2 minus y1 over x2 minus x1. Ladies and gentlemen, this is the formula that we use when we are calculating the gradient. When you have been given the coordinates, I repeat, when you have been given the coordinates and they ask you to find the gradient, this is exactly what you do. I'll also show you what you do if you've been given an equation and they're asking you to determine the gradient. So in this case, what do you do? Given the 2 points, it's very easy for you to determine the gradient because you're just going to label. This is x1, this is y1, and also this is x2, y2. If you're curious to ask a question to say, is it okay to write this one as your x1, y1? Yeah, it's very okay. You surely get the same answer. Just be careful with signs most of the times. Okay, let's try to work this out now. Let's replace, where there is y2, you replace y2. Where there is y1, you replace just like that. So let's try to see what we're going to get. Remember that they have already given us what? M, which is the gradient, which is in this case the 2. Remember, if I was to read through the question again, it's saying the gradient of a line joining the 2 points is 2. So calculate the value of k. Interesting. So now let's start replacing now. Let's start replacing. Okay. So what is m? M is basically 2 is equals to, what is your y2? My y2 is basically negative 14. Then there is minus. Then they're saying, in fact, let me just use the exact color so that you know that the minus is the one that is on the formula. Then let's replace on y1. What is our y1? Y1 is basically k over. They're asking us what is x2. X2 is basically k. Then we say minus, I'll use the same color, minus, what is our x1? Our x1, I would love to replace it in fashion like this, open brackets, then I put my x1 there, because where you're replacing is basically here. So it's very important to replace in brackets like that. So now what do you get? This is going to be, this is 2 is equals to, this is negative 14 minus k over k. Remember that I said negative multiplied by negative, the answer is positive. Wow, we have made that situation now. So there is negative multiplied by negative there. So we know that the answer is positive, and we bring out the 2. From there, I think now we can proceed. So what we have here is an equal sign. So we can just basically balance the fraction, then we cross multiply. So if you have got such a situation, you can easily use cross multiplication, meaning this means that this guy will multiply with that, then this guy will multiply with that, this. So how is it gonna be? Let's try to see how it's going to be. So this is 2 multiplied by k plus 2, then is equals to 1 multiplied by negative 14 minus k. I've just multiplied this one with everything on top here. It's close multiplication. Okay, then 2 with everything that is below there. So that is 2 times k, that is 2k. 2 times positive 2, that is positive 4, is equal to 1 times negative 14, that is negative 14. 1 times negative k, that is negative k. Once again, ladies and gentlemen, let's try to group like terms, and make sure to say, if you've got an equal sign then you're dealing with equations, make sure to say, if you decide for the numbers to be here and the terms, meaning those numbers combined with letters or letters alone, to be here, make sure that you pay attention to how, if something crosses the equal sign, make sure that you pay attention to each sign. Is it going to change, or the sign is going to be maintained? Each time a number crosses an equal sign, each sign changes. In short, what you end up with on the other side of the equal sign is its additive inverse. Yes. So what's going to happen now is this. This is 2x. Then I'll get everything that has got x to this side of the equal sign. So when negative k crosses the equal sign, is going to be, oh, sorry, not x, this is not x, this is k. Then everything that has got k, when they cross the equal sign, that is negative k. When it crosses the equal sign, it's going to be positive k. Is equal to, we have got our negative 14 right there. Got our negative 14 right there. Then we know that this is a number and it has to cross the equal sign the other side. So if it crosses, we know that it's positive 4. When it crosses the equal sign, it's going to be negative 4. Now let's try to simplify this further. Simplifying this further, you will realize to say this is 2k plus k, that is 3k, is equals to negative 14 minus 4. We are basically adding, so that is negative 18. In this case, when you reach there, I don't like dividing from there because I feel like that's a very important stage. So I just copy that, paste it, then I divide. So we realize to say what you end up with is x is equals to 3 into 18, that is 3 into negative 18, that is negative 6. So our x value, why am I using x? Hey, this thing of being used with x, being used to x, okay, yeah. So in this case, our k here, our k is equals to negative 6. So since our k is negative 6, you can go back and write right here, say our k is equals to negative 6, and you are done solving like that. I promised you to say I'm going to show you how you can determine the gradient given an equation. Okay, let me try to come up with something here. So we know that the equation of a straight line is usually in the form of y is equals to mx plus c, where c is basically the y-intercept. Do not be scared with these words. When you say y-intercept, if this is my x-axis and this is my y-axis, any line that crosses, if that line crosses that, that line crosses the y-axis, this is going to be called the y-intercept. So this entire line is going to be represented by the point at which it is crossing the y-axis. So let's think about it. Let's assume it closed at 5. So this entire line is going to be called y is equals to 5. I think you're going to understand this explanation better in linear programming. I'm going to give you these concepts in linear programming. Let's proceed. Let's proceed. Let me just try to do this. Alright, so now we have already stated to say C is basically the y-intercept. Then what is M? M is the gradient. So what I just want you guys to is to understand the exact location of the gradient, because they can give you questions like, given the equation of a straight line, y is equals to, or y minus 4x is equals to 5. Then they ask you to say, find its gradient. This is interesting. So in this case, what I want you to understand is that at first, when we were finding the gradient, we were given the coordinates. That's when you use the formula. Given the coordinates, that's when you use the formula. M is equals to y2 minus y1 over x2 minus x1. But there are also instances where they just give you what is known as an equation. What do? You pay respect to this. Make sure that your line, your equation, is in that exact orientation. So what do? I know that is my y is equals to mx plus c. So now let's try to make sure that our equation that we have been given in the question, this equation must be in that form. Okay, let's write it down. So our solution, we know to say y minus 4x is equals to 5. It's more like I will take this guy right here, I'll take him the other side. So when I take him the other side of the equal sign, I'll just say, okay, this is our equal sign, and we know that I just drop down my y, and this other guy must go the other side, that is positive 4x now. Then that 5 is still there, that is positive 5. Does not close the equal sign, I've just pushed it a little bit forward. So what is it that we have done? So just by having that, it's very easy for us to just extract the gradient, because now this equation is already fitting the orientation of the equation of a straight line to be, which is mx plus c. In this case, our gradient is 4 because this is matching. So meaning this implies that m is equals to positive 4. Like that, it's very easy. Like you have determined the gradient and boom, you're good to go. Yes, so if that's the situation, then let's proceed now to what is known as linear programming. Let's proceed to what is known as linear programming. Let's go to that question. Oh, before I do that, let's first find the equation of a straight line. Or before we find the equation of a straight line, I think you guys can watch out for my part 2 of my YouTube video where we're going to look at linear programming separately. But before we end this video, let's end it with finding the equation of a straight line. Let's end our video by finding the equation of a straight line. By doing so, what I want you guys to understand is, I want you to understand a few things. The relationship of gradients. If I've been given a straight line like that, and another straight line comes and meets that line at an angle of 90 degrees, it's important to note that these two lines are perpendicular to each other. That's one thing that I want you guys to understand. These two lines are perpendicular to each other. Let's call this line A and let's call this other line B. So when two lines are perpendicular, two lines are perpendicular to each other, their gradients can be related by the formula m1 times m2 is equals to -1. In this case, we have used the line A and B. So I would love to say the gradient of A multiplied by the gradient of B is equals to -1. So this is always true when two lines are perpendicular. So if this is the case, let's try to check a question. Let's try to find a question whereby they say, given that the gradient, or maybe I just say given the line, given the equation of a line, let's create a question. Given the equation of a line, y is equals to 4x plus 5, given that the equation y is equals to the equation of a straight line. Yeah, that makes sense. So given that the equation of a straight line y is equals to 4x plus 5 is perpendicular to the line AB, or to the line y is equals to the line kx plus 5. Then they tell you to say find k. Interesting. So the first thing that you need to understand is that why did they give you the first equation and why are they now asking you to find k? It's very easy. Number one, let's look at the two equations. So the first equation is y is equals to 4x plus 5. Is it hard for us to find the gradient? No. We have already explained to say we just need to find out if at all our line is fitting the orientation y is equals to mx plus c. And from this situation, our line is already fitting that orientation. So what do we do? So what we do is that we're just going to get this and say our gradient is equals to 4. Okay, nice. So now remember that it's very easy for me to find the gradient of that other line. Why? Because that other line is perpendicular to this line. And each time two lines are perpendicular to each other, we say their gradients are bound by this equation. Because if you take a look at this line which has got k in it, that equation that has got k in it, it is expressed as y is equals to kx plus 5. So if you dismantle it properly, you will realize to say, if I try to fit in the orientation, like the normal orientation of the equation of a straight line, which is y is equals to mx plus c, I'm realizing to say, in this case, what they're looking for is basically the gradient. And our gradient in this case is k. But what is k? Exactly. So we know that this gradient and that gradient, we know to say that gradient and that gradient are bound by the equation m1 times m2 is equals to -1. So now what do? Let's label this one gradient 1 and let's label this one gradient 2. If that's the case, then what is it that's going to happen? What's going to happen is our gradient 1, if we label like that, it's gonna be 4. That is 4 multiplied by, what is our gradient 2? Our gradient 2, we know that that is just basically m2. If this is our m2, then this is equals to -1. So what do we have? What we have is basically 4 times m2, this is 4m2 is equals to -1. In this case, I don't divide from there as usual. I'm going to copy and paste it. That is 4m2 is equals to -1. Then I divide by 4, divide by 4. Implying that our m2 is equals to -1 over 4. Now remember that we have already stated that our m2 is equals to k. How did we find that? We just found it by just getting that straight line and checking the orientation, and we realized that it's matching with that. And our m2 in this case, since our m2, we have already found the m2 to be -1 over 4, then that is going to be k. In this case, our k is equals to -1 over 4. Like that. That's very easy and straightforward. So the only thing that you need to understand is what is the relationship between the gradients of two lines that are said to be perpendicular to each other. Okay, so let's try to take a look at two lines that are parallel to each other. Two lines that are parallel to each other. So lines that are parallel to each other look like this. These two lines are parallel. So if these two lines are parallel to each other, what is the relationship between their gradients? Okay, without wasting much of your time, let's try to label this line to be line A, and this is line B. So as its gradients to be called like gradient A, and this let's call it gradient B. So what is the relationship between their gradients? Just know that if two lines are parallel, the gradient of A, MA, is always going to be equal to the gradient of B. In short, they have got the same gradient. If they are parallel, they've got the same gradient. Exactly, that's what is happening. Okay, if that's the case, then it's very easy. Each time they tell you that given that the equation so has got a gradient of this and it's parallel, and that equation is parallel to this, like, just know that they are sharing the gradient. Okay, let's try to see how we can find now the equation of a straight line. So there are instances where they can give you in form of a coordinate, or they can give you in form of the graph. Let me use the graph so that I use it as an opportunity to prepare you guys for the linear programming in part 2 of this video. Okay, so if this is our y-axis and this is our x-axis, that's our point, or the origin, which is the chord. Now this time is called because the x or y plane. So now there's going to be a line that can slant like that, like that. In that line, you realize to say at this point and at that point, so we say here it's cutting at 0.5, there it's cutting at 6. If that's the situation, they are calling this point A, then they're calling that point B. Then they can ask you to say, find the equation of line AB. What do you do? First thing first, extract the coordinates at each point. Remember, I've got always the coordinates. The coordinates are x, y. Let's call this one point A. So now let's try to extract the coordinates at point A. Very easy. Follow my footsteps. So remember, this line is cutting the y-axis, right? It's cutting the y-axis at that point. Okay, so if it's cutting the y-axis, let's start labeling. It's very easy. We know that it's cutting the y-axis at 0.6, at the 0.6, so meaning the y-axis is being cut at 6. What about the x? Is it cutting the x-axis at this particular point? No, the x-axis is not being cut, and that's 0. In simpler terms, let's just say the y-axis cuts the x-axis at x is equals to 0. Then the x-axis cuts the y-axis at y is equals to 0. So it's more like the x-axis is called y is equals to 0. So all the coordinates of y in the x-axis are going to be 0. And all the coordinates of x in the x-axis, for so long as the point lies in the x-axis, even if it's here, we know that that particular point y is 0. Let's just find the x. That's what I want you to understand. If this is 0.5, then there's a line that, if I just want to find, maybe not even the line, but I just want to find the coordinates of that point, let's call that point C. Just make sure to say you understand, to say in this entire line from here all the way to the top, wherever it's going to end, just know that the coordinate of x is always going to be 0. That's what I mean. So in this case, since it's x, y, we're going to say this is 0,5. That's point C. If you are capable of extracting the coordinates, it's very easy for you now to find the equation of a straight line. Okay, let's take a look at the equation of a straight line now. Since B now, it's very easy to extract because we know that here we can, it's cutting at x is equals to 5. That is 5, 0. We know that in the x-axis all the coordinates of y are 0. So since now I've got the coordinates, let's write the coordinates that we have. Let's write the coordinates. So our coordinates are, let's write them there, that is 0, 6 and 5, 0. So that is A is 0, 6 and B, that is 5, 0. Okay, 5, 0. So now we can say this is our x1, that's our y1, that's our x2, and that's our y2. Remember that our diagram looked something like this. Our 6 was there and our 5 was there. Exactly. So how do you find? This is our A and that's our B. Exactly. So the equation of a straight line goes by the formula y is equals to gradient, open brackets, x minus x1 close plus y1. Other people, you normally write this equation as y minus y1 is equals to the gradient open x minus x1. So what I've just basically done is to get this guy, I've just taken him the other side so that I just make my work easy. There's nothing different. Don't be scared. We are saying the right thing. We are solving the right thing. Alright, so the next thing that we do is you replace. Just replace where there are numbers. So this is y is equals to, first and foremost, what is our gradient? We can determine our gradient in advance. So we know that gradient m is equals to y2 minus y1 over x2 minus x1. So what is our y2? Our y2 is basically 0 minus y1 is basically, our y1 is basically 6 over, what is our x2? Our x2 is basically 5 minus, what is our x1? Our x1 is basically 0, implying that the gradient is equals to negative 6 over 5. Okay, cool. Then it means that we have our negative 6 over 5 right here. Open brackets. We've got x minus. Remember that we only replace where there is a number. So what is negative? Or what is x1? Our x1 is 0. I've replaced a 0 there. Close. Plus, what is our y1? Our y1 is basically 6. So in this case, this is y is equals to negative 6 over 5 times x. So negative 6 over 5 times x, that is negative 6 over 5x. Then negative 6 over 5 times 0, that is just 0. Then negative, so now we can drop down this guy, which is plus 6. I've written everything so that you guys can follow. This is y is equals to negative 6 over 5x plus 6. In this case, this is the equation of a straight line AB. If you have got any question, you can contact the number 0970 86 55 97. Grand Academy offers online lessons as well. Online lessons, and they come with recorded videos. Remember, share our videos to your friends and family so that they can study with you, they can move at the same pace as you, so that they can get those good grades. Thank you very much. Enjoy.